At the beginning of the lecture, we mentioned two attitudes to data compression within the framework of descriptive statistics: listing the frequencies and calculating statistics. We have briefly observed the first, and now we're going to look closely at the second attitude. So, what is statistics in this context? Descriptive statistics are the quantities that characterize or represent a data set. For quantitative characters, statistic calculations usually undermine a measure of location and a measure of scale. We measure a location by finding a typical or central value that best describes the data. There are three common definitions of a typical value: mode, mean, and median. To measure scale means to characterize the spread or variability of a data set. Variability is a quantitative measure of the differences between scores in a distribution and describes the degree to which the scores are spread out or clustered together. Mode. Today we are going to concentrate our attention on the three basic measures of location. Mode is a universal and straightforward measure of typicality. Mode is a value of a character that occurs with the greatest frequency. It is not necessarily unique. The mode can be used for both qualitative and quantitative characters, yet it is typically used in a qualitative fashion. For example, there may be a single dominant hump in the data, perhaps two or more smaller humps in the data. Mode is the only measure of location that can be used for nominal scale characters. Like in this example with the marital status. And the mode is usually quite evident from a table or even in the list. It is especially evident from a bar chart or a door chart as it has to do with the frequency. Together with mode, range is counted. It is the difference between the highest and the lowest values in a data set. So given the following list of values, 13, 18, 13, 14, 13, 16, 14, 21, 13, we subtract 13 from 21 since the largest value in the list is 21 and the smallest is 13, so the range is 8. For quantitative characters, we will use an arithmetic mean, which is by definition the sum of the values divided by the number of observations. The mean is most commonly referred to as the average. The mean describes observations briefly, concisely, and appropriately, only if all values are in fact distributed very close to it. In contrast, if the outcomes are dispersed very widely around the mean is actually not typical. And then does not well enough provide information about the outcomes of the sample on its own. For example, the mean of 38.5 really characterizes the gestational age of birth in weeks of children with Turkish as a native language in the sample, since nowadays it is a common knowledge that birth mainly occur between weeks 35 and 40 of pregnancy. On the other hand, a mean average of 5 could result from a sample of kindergarten children without this particular age even having occurred once in the sample. The problem is especially evident when outliers arise in a data set. Outliers are surprisingly high maximums or surprisingly low minimums in data sets. For example, we have 10 employees in a work team. One earns 2,000, another 3,000, the third obtains 20,000, and all others gain 2,500. Due to this outlier value of 20,000, we get the mean salary of $4,250. And this is by no means typical for the data set under investigation. Nominal and ordinal scale characters exclude mean calculation by definition. Values of nominal scaled characters merely represent different names or qualities, and for ordinal scaled characters, the different measurement values can only express a rank order even um, even though are represented in numbers, even if they are represented in numbers. The extent of distances between these numbers is not based on content. It is by no means proportional or regular. In contrast, the proportional interval between values must be guaranteed in order to use mean. That is why mean calculation is allowed only for quantitative characters. So with values arranged on an interval or ratio scale. Median. In case of ordinal scaled characters, as well as in case of a qualitative character, which is not distributed very symmetrically, and in case of outliers, the median is an appropriate measure of location. The median is the value of the point which has half the data smaller values than that point and half the data bigger values than that point. Median has to be determined in a different fashion for odd and even numbers of observations. If a number of observations is odd, the median takes on a specific outcome. Um, like in the first example, if the number of observations is even, the median is located between two outcomes. Like in the second example, in this case, any value between the two given measurement values is proper. In general, however, the mean of the two values is chosen. Median is based on the outcomes being ranked. In the process of ranking, the outcomes are ranged in accordance with their values. Then a rank 1 to n is assigned to each outcome. For example, we have a list of numbers 3.4, 5.1, 2.6, 7.3 that we first arrange in accordance to their values in ascending order and then designate their ranking order with the numbers from 1 to 4. As a result, ranks of these data items would be 2, 3, 1, and 4 respectively. In the following list of 10 numbers, a fundamental problem arises because we have several research units that obtain the same value. Here the value of 13 and 15. This is a case of tied ranks or ties. Each observation with an identical value is assigned a mean of all ranks, which would have been assigned for these observations if they had different values. For the list in the example, the three outcomes of the values of 13 would have received the ranks of 3, 4, and 5. We sum them up and count the mean. The mean is 4. Therefore, these outcomes acquire the rank of 4. We do the same for the outcomes with the values of 50. The median is therefore determined as follows. It is just a measurement value for which corresponds to the rank located exactly um, in the middle of all ranks. In our example, the median falls between the values of 13 and 16. So we count the mean of these two values and get the median of 14.5.